Hello, everyone. I'm really happy to see so many of you here today. I hope that you enjoy the conference. My name is Aneta Petkova. I'm from Bulgaria, and I'm the quality chapter lead of SumUp. I've been doing quality assurance for my entire career, and some of the things I really like doing is coding, mostly in Java. I'm a big fan of the agile development, and also I like to investigate unclear fuzzy issues. But what I love are dogs. My company is called SumUp, and we are a fintech company that aims to allow small and medium businesses to accept cashless payments. We believe that software is for solving real issues, and we follow the agile methodology. In keeping with agile, just as many other companies, we believe that test automation is really important for having a successful product. To me, automated tests are almost like the troopers that are protecting us from regressions and allow us to do new things and test new things with much higher comfort and feeling of security. What happens, however, when our tests fail? A couple of years ago, I used to work in a company where we had a monitoring duty. This meant that one QA from the team would be responsible for looking through all the results of the automated tests from our nightly build and analyze the failures. Yes, this is pretty much the build whisperers that Roy mentioned in the beginning of the conference. Our tests were high level and UI, so they were flaky. There were a lot of failures, and it was a very hard job and very boring job to analyze everything. Why boring? Because one of the worst things about this was that failures would often repeat from one day to the next, and sometimes even from 1 week to the next, because the causing defect could not be fixed in 1 day or 1 week. Even though we still had to go through every failure and mark it as ignorable. So it wasn't something that anyone wanted to do. Today at SumUp, we don't have to do monitoring duty because we have continuous integration that is doing it for us. And if a single test fails, the whole build fails, as it should be. But one thing remains the same. Sometimes failures repeat themselves because not all issues can be fixed immediately. Of course, it would be ideal if every time there is a failure, one of the development team would jump in and fix it. But in reality, we often work in very important features that can give us a competitive advantage, and we need to release it as fast as possible. Or we are working on a hotfix that is critical for our existing customers and we cannot delay. So we always have to prioritize and compromise. But we also still have to fix the build. So what people usually do, we go into the code and we disable the tests. Most often by commenting them. Because no test means no problems, right? The real problem is that we often forget to re-enable those tests and we allow for bad things to happen in the future. So what if we could have a framework that can anticipate that a test is going to fail again? A framework that knows whether this failure is very important for us or if we want to ignore it and can act accordingly. Well, if you're already thinking about machine learning or artificial intelligence, I want to tell you that we don't need any supercomputer like Iron Man's Jarvis or anything really advanced, because what we need is data. And this data we already have. It is inside your bug tracking system, whatever you use. In our case, it's Jira. Jira knows about all your already existing defects, and it knows how important they are for you. So what I will show you today is a way to combine these two and utilize their power together. The concept is fairly simple. The first thing we need to do is we need to build a connection between the issues that we have in our bug tracking system and the test cases we have in our automation framework. Once we have this, we want to only filter the defects that have impact on our automation. And then we want to make the framework aware of those defects, allow it to execute them. And if we are feeling a bit adventurous, we can allow the framework to talk back to the bug tracking system and report the results or do some other actions. My topic is going to be fairly practical, and I'm going to be showing you some coding examples. And what I will be showing you is a Java tech stack. On one side, I'm using a framework that is based on Test and Grunner. I'm using REST Assured for consuming REST services, and Jackson for working with JSON objects. My bug tracking system is Atlassian Jira, and I'm going to be using its REST API. By the end of this presentation, I hope to show you how we can combine those so we get our very own Voltron defender of the quality. So let's dive into the implementation. The first thing that we need to do is to actually link the defects and the test cases. The way I chose to do this is by introducing a custom field in Jira, which will contain the list of all the test cases that are affected by this defect. And the really important thing here is to pick an ID for your test that is unique. For the example, I went with the class name plus method name, but those of you who are writing Java know that this is not guaranteeing us uniqueness. So you have to think carefully how to pick this, because you only want to disable the tests that are affected by this defect and nothing else. Also, keep in mind that to add a custom field to Jira, you will have to have admin rights to your instance. Now that we have this on, we need to think about which are the defects that our framework needs to know about. And the first criteria is pretty simple, of course. It's only the defects that have this custom field populated with at least one test ID. So tickets that affect at least one of our test cases. But the second criteria is really important. We only want to include lower priority defects. Because if you have a major defect, we would want our build to fail. We don't want to enable any tests to pass if they're, or to be ignored if they are affected by a critical defect. And finally, we only care about currently active defects. Anything that's already been fixed, we don't care. For the actual implementation of this filter, I chose to use Jira's pre-saved filters, because then I can build the filter inside Jira's UI. And this can allow people that do not have programming knowledge to also participate in building this filter and give you their input. But also you can update the filter at any time, and you don't have to rebuild your test framework. You don't have to rebuild your code, because all the criteria will be inside Jira. And you'll be even able to include or remove a particular defect. Finally, when I move a little bit further with the presentation, you'll see that writing JQL inside your code, which is the Jira query language, is not that nice. So I'm just lazy and I like to let Jira do it. One thing you need to consider if you go with this approach, however, is the permissions of your filter, because it needs to be shared at least with your automation framework user, but you also will not want to make it completely open, because if someone changes it by mistake, it will affect all your test runs. Now that we have our defects filtered, we want to feed them into the framework. And for this, I'm going to use Jira's REST API, which is pretty extensive, and it covers almost any action that you can do through the interface. The endpoint I will be using is the search one with a GET request, and I only need to tell Jira two things. The first one is the expression, which tells it which issues I want to see. And in my case, the expression is only going to consist of the ID of the filter that I've created, and then the fields that I want to see for every defect. In my case, I will want the defect ID, its name, its status, and of course, all the test IDs that are associated with it. To work with Jira's API, you will need to authenticate yourself. It's completely straightforward using basic authentication. And I would advise you to have a separate user created for your framework and not put your own credentials in there, because it will be harder in the future to understand who did what. Now, to make the API call, I'm using Rest Assured. Of course, there is no reason for you to go with this particular library. You can do whatever you want for consuming REST services. But as I said, it's really easy. I'm just telling it the idea of the filter that I've created and listing what I want to see for every ticket. From then on, it's just authentication and standard HTTP headers, content type accept, and I'm getting all the data that I want. Jira is going to reply you in JSON, and to make working with it a little bit cleaner, I've created a Jira issue object representation in my framework, and I'm using Jackson to unmarshal the response into my own Jira issue object. The only specific here is that Jira is using some nested JSONs, so you have to put a tiny amount of work to make it look right. Probably the most interesting part here is how you actually disable certain tests before your execution. And here I'm using TestNG's capabilities, and in particular, the iAnnotation transformer interface. This is an interface that fires up before any of your tests is run, and it allows you to programmatically control how your suite looks like and what tests you include or not. We only care about one method in here. It's called transform, and it gives you an access to your current test method object, which allows you to construct your test ID, and if it matches anything that you got from Jira, meaning that it is associated with an active ticket, you can just disable it. And then you will not have ignorable failure in your end report. So let's do a quick recap of what we just saw. First, we need to create a custom field in Jira that is going to contain our test IDs. Then we want to create a filter in Jira that is going to display issues related to our automation. Then we pull those issues into the framework. We disable any compromised test cases that we have. And finally, we get a healthy build. So instead of just talking to you, I want to show you how it works. It's a live demo, it's not a video, so I really hope it works. Okay. So this is my Jira instance. It's a local one. And that's a ticket I've created. It's a defect. Actually, it's associated with certain test case, and it's open. So what I really want to show you here is that the whole implementation takes literally 4 classes. So here I have the classes that are working with Jira, and then here I have 2 classes that are working with TestNG, and this is everything that we need. The Jira issue class is containing, it's just a simple representation. It has no logic inside of it. It doesn't do anything. And the Jira client issue, the Jira client class is the one that is actually talking to Jira and working with the REST API. So this is my test class, and this is the test that I put in Jira. The class is login test, correct credentials test. Now, because I want this test to be disabled, I'm going to change the priority and put it to low. Then I have a pre-saved filter, which is called active automation blockers. And as you can see, it is showing my ticket with ID drag 4. Because my criteria is test ID not empty, status category not done, and priority lower or equal to medium. So now when I get back and I execute my tests, we can see here that there is a warning message that is telling us we have a test case that is disabled, and it is giving us the ID of the ticket that is causing it. So if we want to investigate further, we can. And if we look at the TestNG report, we can see that we have 1 method passed, and we have 1 method that is ignored. This is the method we put in the Jira ticket. Now here there is something important. TestNG makes a very big distinction between skipped tests and disabled tests. When you skip a test, this means that the test should have been executed, but for one or other reason, TestNG was not able to. Typically, it's a failure of a begin method, and then your build is going to fail. When you disable a test case, what we are doing right now, this means that you don't want this test to be executed, and this will not fail your build. So let's continue. And as I said in the beginning, there is an optional step that you can do. I would recommend you, if you decide to try this, to first start with the first part, and if you decide that you like it and you feel okay with it, then continue to this one, because this part is going to affect your bug tracking system, and you're probably sharing it with a lot of people that you don't want to get angry. So what we would like to do is, well, we already know that certain defects are related to our automated test cases. So if a developer marks a ticket as resolved, and I have an automated test that is covering it in my framework, I can make the framework put a comment in the ticket that is saying, okay, yeah, the test passed. So then another QA can look into this, decide if they want to resolve the issue. Or if the test fails, I can automatically reopen the ticket and return it to the developer, because obviously something is not working. For this, I'm again going to use testng, and here it is giving us two great methods, on test failure and on test success, which come from iTestListener. They allow you to perform specific actions after each and every test is complete. Now, because those methods are executed after every one of your test cases, you would not want to make network calls to Jira after every test, or it will be really slow. So you can create another pre-saved filter which contains only defects that are resolved in the last day or whatever time frame you choose. If you're running your tests very frequently, you can do it 4 hours or however you feel is the best for you. And you would want to pull the list with all the tickets in the beginning of the execution and not when you're doing the check. So you have the list and you don't have to do more network calls than necessary. The Jira endpoints that are allowing us to do that are the comment endpoint and transitions, which is going to allow us to update a status to something more specific. So let's see how this one works. So this is my test case, and I'm going to mark it as a resolved. It still has the test case association here. So then I go back to my code. And I'll see if I can make it bigger. And actually, I've made sure that this test is going to fail. So it will consider that resolved defect not really resolved. Okay, now we can see that the build failed because this test is no longer disabled since the issue was resolved and there were failing tests. So that's my report. We can see the failure. And if I get back to the issue, we can see that its status was automatically changed to reopened. And so that we don't wonder what just happened, the framework also left a comment telling us exactly which test case was failing. So now, even if you have a person on the team that is reviewing all those tickets and making the final decision, they have at least more information and more context to go on. But of course, we are quality engineers, and we are doing risk assessment all the time, so we always imagine the worst thing possible, and the night for us is usually dark and full of terrors. So which are the bad things that could happen? Well, the worst thing really is that you can allow unhealthy builds. If you ignore too many tests, or if you prioritize your issues wrongly, you may skip important things. Another thing you could do is you could overrun your bug tracker with comments. If you're putting a lot of comments to the same ticket over time, this can create a lot of noise. And you could open or close defects that you shouldn't have done. But of course, for everything, we can find some solution. So the most important thing is that you really prioritize your defects with care. I'm sure that we all are doing it anyway, but if we do something like that, we must be aware that the priority we put on a defect may mean, is this going to stop the build or not? And to not have too many comments, something that we can, again, use Jira's API for is we can check if there is already existing comment with the same content, and we will not going to create repeatable entries. And finally, if you see that you are reopening things too often because you have false failures and something like that, you should either review your tests and maybe you have to eliminate some flakiness, or maybe you just can give up this last part because it's a bit aggressive. And now that we've talked about the risks, let's talk a little about opportunities. So is there something else that you could be doing with this idea? Well, the first thing is that if you are doing some sort of monitoring and if you have a team that is doing some investigation of builds and failures and things like that, you can use your framework to log a ticket with the result of your run, and it can attach to this ticket logs and all the data so that the person doesn't have to go to different systems and put this data manually, but they have it neatly in a ticket and they can just do the actual brain work. Then you can actually use the framework to raise a flag if a defect is being ignored by the development team for too long. So if you keep ignoring the same test because something is not being addressed, then probably some people need to decide if they're going to fix it or if they're going to declare whatever this is a feature. Another thing is to analyze the frequency of your test IDs that are being disabled. Because if you have these 3 automated tests that are being disabled almost weekly, then you can see to which feature of your product they're related, and it means that your feature has some serious underlying issue if it's breaking that often. And then you can go and do some root cause analysis, and maybe you will fix it once and for all instead of doing small fixes here and there. But one of the most valuable things about this is that it can help you to improve your own test quality. Because if you see that you have 40 tests that are being ignored on a daily basis, it probably means that those tests are related to functionality which you don't consider high priority. And then you can ask yourself, am I automating the right things? If I can allow to ignore that many things, maybe I don't need those tests at all. And also, you might realize that you're writing tests that are really long and really complex, and they're touching too many functionalities, which makes them prone to breakage from a lot of different issues. So you could be addressing that. And my goal here today was to present you with a simple technical solution that can help you save time by removing some of the repeatable and unchallenging work that you might still have to do. But just like the giant robot that I chose for my slides, Voltron, this is nothing but a tool. And if you have seen the anime, Voltron doesn't matter without the team that is piloting it. It is about software engineers to choose the right tools and to choose the right application for those tools. It is only us that can truly make a product successful. Thank you so much for being here. Feel free to reach out using any channel you like. And now I will open Slido to see if there are any questions.
Товарищи, если у кого-то есть вопросы из зала, то тоже можете задать. У нас есть микрофон. Извините.
Thank you for your presentation. I have a quick question about the long tests. So our problem is that we have lots of integration tests, and there are lots of checks in it. And it can fail, the specific check can fail, and we want to ignore this check, not the entire test, because there are lots of things also running it. Do you have any thoughts how to do it? So basically, we couldn't ignore like entire tests like you do.
Yep.
Have you thought about it, or maybe you have some other ideas how to do it?
Well, we did do something like that in a previous company. So we had something like feature flags in a property file, and you can disable just a single flag, and then in your tests we were checking if the flag is active, we are going to execute this portion of the test, but if it's not, then we would not. Like, the real reason we did it was because the product was configurable and certain instances have something enabled, others not, but I think it could be used in your context.
How about lower priority features which affect several tests? And I see you linked one test ID to one issue. And it happens when one issue break some
Multiple
functionality
tests.
with lower priority, but it has several tests. How do you look for it?
Yeah.
How?
Well, the reason I went with this field in Jira is that it will allow you to input as many test IDs as you want. So you can just list all the tests that are affected and, it will ignore all of them. Did I get it, or was it something else?
Hello. Thanks a lot for your presentation. I have one question. I saw that test ID is class name and test method name. Did you have any problems in refactoring your code? Well, for example, when you needed to modify class names or test methods?
I think we didn't have to do this until now, but the proper thing would be to check if you have any open issues related to this in Jira.
Okay, thank you.
One more question. When your test fails, when you ignore your test, you skip them and you see it in reports. But how many people look in the skipped errors? Have you any reports that shows you skips some tests on?
Yeah. Well, because what I'm showing here is a demo project, and you can actually see it in my GitHub and download the code. This is not a production version, and so this report here is the built-in test and G report. But you can customize the report itself, and you can put here, for example, besides the list of the ignored methods, you can also put a list of the tickets, like you can customize it. And if no one is looking at this report, then I don't know why you're doing automation.
Еще вопросы есть? Или можем открывать слайды? Нет? Окей. Товарищи, активнее. Okay, so thank you very much.